MSSP in PIC 18. MSSP is Master Synchronous Serial Port. In PIC 18, this MSSP Master Synchronous Serial Port is a serial interface useful for communicating with the peripherals or microcontroller devices. These peripherals may be in the form of EEPROM, shift register, display drivers, A to D converters. This MSSP can operate in two mode of operation. One is SPI, which is also known as a serial peripheral interface, and I2C, which is nothing but inter-integrated circuit. In SPI peripheral interface, serial peripheral interface, there is a communication between SPI master and slave over 4-wire connection, and that connection is chip select, which is also referred as a slave select, SS bar signal, S clock signal, serial clock signal, MOSI, master out serial in, and MISO, master in serial out. So the communication will take place in between master and slave configuration. In SPI, the basic two mode of operations are there, MOSI and MISO. Now this MISO and MOSI is nothing but master out, slave in. So your master will able to transmit, that's why master out. Slave will able to receive in that mode of operation, that's why it is referred it as a MOSI, and similar to that MISO. So when in terms of MISO, master in, so your master becomes in the reception mode and your slave will be transmitting it. That's why slave out, master in. Another type of configuration is I2C, inter-integrated circuit. In I2C, you can communicate with peripherals, that too with many peripherals one at a time. So one master will be there and multiple slave configuration will be there. And the communication will get established over only two lines, SDA signal and S clock signal. So major difference in between SPI and I2C communication is one can provide multiple slave configuration in I2C, whereas in for the SPI mode there is a configuration of master and slave over 4 wires, and here in I2C only 2 signals are required for communication. So to accomplish communication, typically 3 pins are majorly used: SDI, serial data out; SDO, serial data in and out; SDI, serial data in; SDO, serial data out; and slave select signal. Along with that, one more signal is required, that is S clock signal. So your MSSP module can utilize under the SPI mode using 4 pins. Now here, the communication will be taken place on the basis of 4 basic registers, and that is SSP con register, SSP stat register, SSP SR register, and SSP buff register. So the data to be transmitted and received under the SPI mode has to be loaded in SSP buff register. Whereas in this SSP buff register is associated with the shift register. Using that, your data will be serially shifted either out or in. In that manner, both of the operation of whether your master wanted to send something or whether master wants to receive something, in both of the manner, read and write operation can be taken place using the SSP buff register. Now, as this is being enabled with the slave select signal, and whole communication will be taken place with the S clock. So, in order to that, S clock signal will be utilized. So, in that manner, this serial transmission over 8-bit signal can be utilized in the case of SPI mode. Even for the rate of communication can be taken place with respect to the pre-scalar. So there are variety of options for SPI mode to utilize this clock frequency And in order to that, you can utilize again timers in that respect to utilize under this particular SPI mode of operation. So here the shift register that is associated with your SSP buffer register is used for shifting the data in and out. This SSP buff is the buffer register to which the data bytes are to be written or to read it from. That's why read and write signal are associated with it. In receive operation, SSP SR register and SSP buff register together to create a double buffer together for the receiver side. So when SSP SR receives complete byte, and it is transferred to the SSP buff register, and in that manner the completion of reception will be indicated by the interrupt flag, and that interrupt flag is nothing but SSP IF flag, and that flag will be set. So during the transmission, now in that manner another case for the transmission will be SSP buff is not getting doubled. So in that manner the data to be written onto this buffer register will write to the both the shift register as well as buffer register. But unlike in the case of this particular reception, so in that manner there is a buffer will get double, but in the transmission this will not get double. Now when the initialization the SPI, the several operation needs to be specified. Now in that manner some of the control bits are there where through which you can able to specify master mode, slave mode, clock parity, data in sample phase, or clock edge, clock rate, slave select mode. So in short, your MSSP module consists of transmit, receive, shift register and buffer register. So along with that, data in and out from that respective device can be taken place. So the MSB first will get transmitted and getting out it out of your data first rather than LSB. So SSP buff register holds that respected data that was to be returned to the SSP SR until the received data is ready. So once the 8 bits of data has been received successfully, that the byte is moved to the SSP buffer register. Then the indication of your buffer full and empty will be indicated. So in that manner, whether it is full and empty, that user will able to identify. So this is the typical connection diagram for SPI master slave. In that manner, SPI master and SPI slaves are connected over 4 lines that can be SDO, SDI, S clock and SS. So that SS line will be nothing but enabling your slave. So in that manner, these two master controller that will be initiated, whoever is initiating first, that becomes the master. So here, let's say processor 1 have initiated first, so this becomes master. So it initiate the data transfer by sending S clock signal. So as and when S clock signal is initiated, your master is ready to communicate with the peripheral or with the slave. So as this is serial communication, your data will get shifted serially out, and from that out it is going to your slave side. That's why SDI pin will able to receive it. Now as and when SDI will able to receive, so data is shifted in both of the side serially shift register that are used, and those are programmed with your clock edge. So in that manner, both the processors should able to program on the same clock priority. So if you are mentioning high to low priority for the master, same priority has to be mentioned for the slave. So it is mandatory thing. Then both the controller, maybe this one and this one, could able to program with the would able to send and receive the data at the same time. So in that manner, whenever master sends the data, slave will again sends the dummy data of it. Now when master sends it, in that manner slave will able to receive it. Now these are the 4 pins are required for your SPI. Now as repeatedly discuss about, all the pins are multi-pin functionality. So your SDO, SDI, S clock and SS signals are associated with RC7, RB0, RB1, RB5. You can able to see all these pins in the data sheet itself. Pin diagram can able to specify all 4 pins associated with the individual respected port bits. Now in SPI mode, the basic 4 configuring registers are required to operate this MSSP under the SPI mode. Those are MSSP control register, MSSP status register, Mssp buffer register and Mssp shift register. Although this shift register is not directly accessible to the user, but yes, of course, serial transmit and receive buffer register, that is SSPBUF register, is accessible to the user. So the data to be transmitted or the data to be received has to be gone under through this SSPBUF register. Now let's discuss about Mssp status register. The name itself is telling you that status. So after the communication, status will get updated here in this status register. So let's discuss one by one bit. Very first bit is SMP bit. SMP bit is nothing but sample bit. So you can sample your bit under the SPI master mode as well as SPI slave mode. But when you are utilizing this SMP bit in master mode, it has to be 1. So indication is nothing but input data is sampled at the data of output time. And where it is 0, that indicates that input data is sampled at the middle of the time. So as we are discussing here in this diagram that both of the clock are associated with the triggered at the same level. So in that manner, when SMP bit is 0, that sampling will be taken place from your master's side, that will be at the end of the data output line. Whereas if you put this bit as a 0, in between middle of the data line, the output data will be sampled. In slave mode, this SMP bit must be cleared in slave mode. Next bit is CKE bit. CK is nothing but clock enable bit. Now there is a transition of the clock, maybe from when you put this bit as a 0, transmit your clock at the from the active to the idle state. So from high to low transition, whenever this bit will be 1, and at, as this bit is 0, the indication will be from idle to low, that is active, that is nothing but low to high transition clock will be enabled. So at the time of that level S triggering transition, your transmission will be taken place. D slash A bar, that is nothing but data slash address. So when this bit has a 1, means data is associated with it. When this bit has a 0, means address is associated. Now as this MSSP under SPI mode, only one slave is there. So there could not be any multiple slave addresses are generated under SPI mode. So this particular bit is used in only I2C mode. So this bit is not used under the SPI mode. Next bit is P and S. P and S is nothing but stop and start bit. This stop and start bit will be used under the I2C mode. So this will be initiation of the communication, and this will be to know the end of communication. in both of the manner, these 2 bits are, even rather than these 3 bits are used in only I2C. It is not used in SPI mode. Next, R/W bar means read and write information bit. Now this read and write information bit will help you to read the data and write the data in order to that you can able to have an access to the read information or write information. Next bit is UNA, update address. Again, this bit is utilized in I2C mode where you wanted to update the slave address. Next is indication of whether the buffer is full or buffer is empty. When this bit is 1, indication is your SSPBUF is full. Means this particular bit in the diagram. This particular block. So there is an indication of this SSPBUF whether it is full and empty will be identified using BF bit, and which is nothing but the buffer full and empty status. Next register used in SPI mode is SSP-con register. This SSP-con register is MSSP control register 1. Now to utilize this register in SPI mode, let's discuss the mode of operation for this SSP. 4 bits are there in this register. Those are master synchronous, serial port, mode select bit. So in order to that, if you place these bits as a 0, 1, 0, 1, the mode will be selected as a SPI slave mode. So in that manner, the kind of SPI slave mode will be the clock, S clock pin will be enabled, SS pin will be, SS bar pin will be disabled. In that manner, you can utilize this SS bar can be used as a input and output pin. Whereas in for 0100, again this will enable the particular SPI in slave mode, but the difference between this SPI slave mode and this SPI slave mode is SS bar pin under this particular mode of operation will be disabled, and whereas in for this case as a 0100 SPI slave mode, SS bit will be enabled. So this is the only one difference in between these two slave mode. Next is SPI master mode. So 0011 is SPI master mode, and for this mode of operation clock will be given from your timer 2. Similar to this, again SPI master mode is there, but the clock source is now system clock divided by 64. This will be considered as a bit combination, not specified as enlisted, either the reserved or implemented in the I2C mode. But yes, of course, for this SPI mode, you can utilize this under the master mode where the clock frequency is FOSC divided by 64, where FOSC is nothing but system clock. So likewise, few more options are available for master mode where the clock frequency is only getting changed, rest of the things will remain same. So likewise, another option for master mode for the clock source is FOSC divided by 16 as well as FOSC divided by 4. Next bit is WCOL bit. This WCOL is nothing but write collision bit. Now in the case of write collision bit, when this bit is 1, the respected SSPBUF register is written while it's in still in the transmitting the previous word, and whenever this bit will be 0 means there is no collision of it. So the indication of whether the previous data is transmitting or not, that will be defined through the collision bit. Next is SSPOV bit. Now this SSPOV bit is nothing but overflow indicator. Now this overflow indicator will be in the case of when this bit is 1 means a new byte is received from your SSPBUF and register is still holding the previous data. So in this case the overflow bit will get enabled. In that manner, the data in this SSPSR register will be lost because overflow is occurred. Overflow can only occur in slave mode. So the user must read the SSPBUF register even if only transmitting the data to avoid these kind of overflow settings in the transmission as well as reception. Next is SSPEN bit. Now SSPEN is nothing but to enable this MSSP module. So if you put this bit as a 1 means you have enabled the SSPEN module, otherwise SSPEN will be disabled. So until and unless this won't be enabled, you cannot utilize under the SPI mode. Next is clock polarity select bit, CKP. Now this CKP, the polarity selection for the clock from the low level to the high level or from high level to the low level, that will be indicated from either by putting the value as a 1 or by putting the value as a 0 for the transition of that clock, that will be identified using the CKP. So this is all about the control register one under the SPI mode. Now let's check it out how to initialize the SPI module in master mode. So there is a configuration setting for master as well as slave. Now to configure your MSSP module under the SPI mode, that too with as a master, so whoever is initiating first, that becomes master. So to configure your master, the S clock SDO pin has to get set as a output and SDI pin has to be enabled through the input using trace register. After that, to configure port pins as an output, you need to select the chip select or slave select because this is the output pin. In third step, need to select CKE bit and SMP bit in SSP stat register. These two bits we have seen it previously, that is CK is nothing but SPI clock select bit. So the transition of the clock from the active high to active low state or from active low to active high state, that decision will be taken care by CKE. Along with that, SMP bit is nothing but your sample SPI bit, that too within master mode, because here we are initializing the settings for master mode. So for that purpose, in third step, we need to initialize CKE bit and SMP bit in SSP stat register. After that, in fourth step, we need to enable SPI under the master mode. So in that manner, we have seen SSP con 1 register, lower 4 bits are nothing but mode of operation under the SPI mode. That to which we are doing the setting initialization setting for SPI master. That's why we need to select all either of the one option required for to set the SPI under the master mode. So let's say if we have set the SPI setting as a master mode with FOAC divided by 64 is the clock source applied under the SPI mode for the master, and at the end we have to enable the SPI in SSP con register by setting SSP EN bit in SSP con register 1. So like this way we'll be able to initialize the master mode. Similar to master, if at all we wanted to send data to the slave device, again we require some of the steps for setting these kind of data to the slave device. So very first thing is we need to select the slave device by making maybe the SS bar signal as active low. So here the fourth signal to select your slave device is SS bar signal. After that, we need to take the data. If at all you wanted to transfer that data, maybe let's say as a hello, how are you? This is the data is there which you wanted to transfer to the slave device. So the data that we wanted to send to that slave device has to be loaded to the SSBUF register. Then we need to check the status for the transmission, by which particular bit will able to know that whether the transmission is completed or not, on the basis of BF bit. So transmission successful or ongoing process, that will be indicated by buffer full bit in SSP stat register. And after that, if at all you wanted to disable the device, you will simply deselect the device by making SS bar signal as an active high signal, and communication will be completed. So like this way, you can send data to the slave device as well in this manner. Now let's say if at all you wanted to initialize SPI initialization function, and that is to be written in embedded C language. So here let's take a look out for SPI initialization function. So as 4 pins are there, and those 4 pins are nothing but S clock, SDI, SDO. So in that manner we'll be able to set the direction of all these 3 as per the setting of output and input direction. So which is nothing but RB1, RB0, RC7. You will able to know this by looking upon the pin diagram for PIC18F4550. So from pin diagram itself, I have figured it out which respected port bit is associated with S clock, SDI, SDO. Likewise, you will be able to identify all the port bits required for maybe for SPI or maybe for I2C. After that, we are simply clearing the initial data where your S clock is cleared with 0 and SDO is initially cleared with 0. If at all this particular SPI is initialized with the, let's say you have connected PIC18 microcontroller, and that is connected with the peripheral device as a E-square PROM. Now E-square PROM itself have some kind of commands to get initialized. So in order to that, we need to enable that respected E-square PROM IC. So through that you will able to transfer the data from microcontroller PIC18 to that E-square PROM IC. So for that purpose, we need to enable chip select pin, and which is nothing but your chip select pin required for your E-square PROM IC. That pin number we have to enable it as a output because that is connected to your PIC18 controller. After that, initially your slave is not selected, so for that purpose your slave select bar signal which is connected to microcontroller, that is kept as a 1. After that, if you wanted to sample the data in the maybe in the case of middle of the data or at the end of the data, for that purpose you will take SMP bit in SSP stat register. You will able to see this SMP bit details in SSP stat register. After that, check the transition polarity for CKE, and after that set the setting for the microcontroller master clock as per the setting required in the SSP con register, and then enable your module. So like this way you will able to initialize SPI under master mode initialization.